And you might say that surprises you, but the yellow guy says, no, it's not so surprising because, things get so much bigger. We blow up the size of things so much. And then, the devil is getting to be sort of sarcastic, and he says, well, here is a reasonably simple, generalized regular expression. Remember, it has an intersection, and it has a complement, which makes it generalized. So that means you should be able to write the same language using a regular expression without the complement and without the intersection, right? So then I thought, well, should I do such an example? And here is my banging along, hand-wavy attempt at doing it. And you can decide whether you want to do this on your spare time. You could play video games, or you could do these things once, on your spare time, right? So we're gonna from that we're gonna create a DFA, and then I first started thinking, oh, well, I'll keep it as DFAs, but they got so ugly. So you'll see, I quickly moved to NFAs, and then from the NFA we'll go to create a regular expression, right? So we first are going to take our expression and break it into parts. All right. So here we have a first part. Here is an example. What do you get as a DFA? Well, you say, oh, is that a DFA for it? And then you say, well, it's not actually a DFA. A DFA actually needs a dead state. And right, everybody see that this is sort of A star B B except, but we don't have A's coming out of this, so really you need a character. And if it's going to be a DFA, you need all these guys coming out, so you have a dead state. All right, so that was fun. Let's create it. Let's stick to NFAs. It was at this point I realized, hey, maybe I was using, back in the day when I made these slides, I must have been using blue for NFAs and DFAs and purple for NFAs, but I must have forgotten that at some point. All right, so now we do our other pieces, right? We build a little NFA for the A star B, and a little NFA for A star, and a little NFA for B star A, B star, right? And we're starting to build up these pieces, right? What? Well, we're going to have to do this union. We're going to have to do this complement. We're going to have to do this. I'm going to have to do all those parts. There's lots of hairy. Did that answer your question? We just build little parts now, right? And then now we're going to take those first two things and union them. And there, it's an NFA. We can union them just by putting this epsilon transition, right? That wasn't so bad. And now we want to do a complement, right? So can we complement like this? No. Everybody remember, NFAs, you can't complement like this. So count on, that would be a good thing to test you on. Can you complement like this? Everybody remember why you can't is because there are multiple paths here to different states. And it accepts if there's one path to an accept state, and you complement it, and then there could still be a path to an accept state, and so it doesn't give us a complement. So that was a good thing to try, but it was wrong, right? So we have to turn it into a DFA, and so we do our whole gnome thing, and we get some ugly DFA out of it, right? Which I skipped. Yes?
But when you're at the DFA for the first part, can you just complement it and use the Morgans? It's just like A, D, complement, intersection, A star, B, B, complement.
Yeah, but when you do those complements, you're still going to have to create into a DFA, and it's not going to, I don't think that'll help us any. I don't think that'll help. Anyway, now we have a DFA for that piece. Now we can do the complement, right? Using just switching the accept and the reject states. So that gives us our first piece. And then we're going to take this this crazy piece and concatenate it with A star. And how do you do concatenation? Well, remember we said we can do concatenation. Anybody remember how we do it? We do that cross product thing. Right? So, let's see, where are we doing it here? Oh no, I guess if we turn it back into an NFA, then we just have to do an epsilon transition, right, to do this concatenation. That wasn't so bad, right? Are people sort of following along? So now we have something for that piece, and then we have to intersect it with the other piece. And when we intersect it, that's when we have to do this cross product thing, and we get something even bigger, right? Cross product of those two examples, and we get something big and scary. And then, now we have this big scary thing, and we do what we did just a minute ago, ripping nodes out one at a time. We do rip, 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 and we're glad that we didn't actually have to do it. Everybody kind of buy that?
Professor, in the previous example, you converted the NFA to a DFA to like complement it.
To complement it.
Then you translated it back to an NFA again.
Yep. Yep. I was trying to always do the easiest thing.
So is there any other way rather than doing that way instead of just translating it back and forth?
I don't know of any other way to do it. So sometimes it feels like you have to do the translation a number of times. And so does it grow exponentially each time so you get double exponential growth? I don't know the answer of how bad it can be. But it certainly can be bad.